Okay, this question is just asking you to calculate a pH, and that can seem fairly straightforward, but there's a couple of slight twists to this. One is that we've got a solution of a weak base here, and we've had acid added to it, so that makes it a little bit more complicated in that this has been partially neutralized. So this is kind of like doing a titration of, or in fact it is like doing a titration of a weak base with a strong acid and stopping part way through and asking what the pH is. So you could have a similar question like that, and these would be really exactly the same. So obviously if you were to do a titration of 25 mils of 0.1 mole per litre CH3NH2, if you were to completely do the titration, you'd have exactly 25 mils of 0.1 mole per litre HCl added to it, and all of this would be converted into CH3NH3 plus, the conjugate acid. And this is different in that we don't have 25 mils of this, we have 15 mils of it. So that means some, or actually the majority of it really, but over half of this has been converted into the conjugate acid. And once we know that, we can work this out. Now, if we wanted to know the pH, now if you're doing a kind of, just looking at this, is if we do that, it's a very kind of poor titration curve, but anyway, at the start of a titration, before we've added a single drop, if we just had weak base, we would use the weak base formula. If after adding 25 mils of acid, so at the very, so at the end of the titration, which should be more of a straight line there, but it isn't, but at the end of the titration, if we wanted to know the pH, we would use the weak acid formula. Anywhere in between that, really, we've got differing amounts of the base and the conjugate acid, and therefore we cannot use the weak acid formula, we cannot use the weak base formula, we just use either a buffer formula, or in this case I encourage students just use the straight Ka equals, and this would be CH3 NH2 and H3O plus over CH3NH3 plus. So we're just going to use that formula there, which is derived just from the expression for the dissociation, or the equation for the dissociation of the weak acid, and we just can plug some numbers in there. And obviously if we're working on pH, what we're wanting to find out is hydrogen ion or the hydronium ion concentration. Ka we already know from the previous question, because we were given the pKa, I think it's equal to 10.6 for this, and we just need to convert that into a Ka and then work out what the concentrations will be. The other trick to this question is just recognizing that when we work out how many moles of both the base and the conjugate acid, that the volume isn't just 15 mils, it isn't just 25 mils, we have to combine those. It's the total volume that we're interested in, because remember, it's concentration equals moles divided by volume, so it's the total number of moles of whatever we're interested in divided by the total volume that we're interested in, remembering that's got to be in litres, so try to avoid those simple mistakes in doing conversions. Okay, sorry about that. Okay, now let's have a go at this calculation. Okay, so if we set this out again, this is just the equation that we're going to be using. I haven't done the conversion of pKa of 10.6, but that's just going to be inverse log minus 10.6, execute, and that should give you your answer, which we'll do shortly. But if you remember the equation for concentration equals moles divided by volume, so if you want to work out the moles, it's just volumes times concentration. So for the acid here, it's going to be 0.015 times 0.1. and that gives 1.5 times 10 to the negative 3 moles, and we do a similar equation for the base, and that's not 2.5. Oops, just a mistake there, because if we have 1.5, if we have 15 mils and 25 mils, that means we've only got 10 mils at that stage, so I'll just change that. We've only got 25 mils in total. And so we'll just change that because it's 15 mils here and 25 mils in total of the base. So obviously 25 minus 15 is going to be 10, which is why that should be 10 down there. Okay, so we've got, that's 1 times 10 to the negative 3 moles. So that's the number of moles of each of those, but we need a concentration, so we divide it by the total volume. So that's going to be divided by 0.04. So, because it's obviously it's got to be in litres, and that will give us our concentrations for this. There we go ahead and we do it, and we'll find that this is 0.0375 moles per litre, and this one's 0.025 moles per litre. And the Ka, if we do that, which I'm just going to do right now in my calculator, inverse log minus 10.6 equals 2.51 times 10 to the negative 11. Okay, so if we go ahead and we now do that calculation, we should be able to work out what the pH is. And if you substitute those in, you should be able to get a pH equal to 10.4, remembering you've got to convert the hydrogen ion concentration once you get it into a pH, which is just straight minus log of that number. Okay, and that's question B done.